All right, this is first grade Module 2, Lesson 11. And in this lesson, students are going to continue using a variety of strategies for addition. But we're going to constantly focus on efficiency, beauty. Why'd you choose one strategy versus another? What was it about the numbers in the problem that caused you to use the count-on method versus the number bond method, etc.? The idea of all of this, really, if you get right down to it, is let's get the kids talking about math more often. Using my favorite format is number talks. If you don't know about number talks, please, please, please consider going to bit.ly/number talks by Duane as one example. There's a bazillion examples out there on the internet of what is a number talk, how to conduct one. We know through research, the more kids are talking about math, the more they're going to learn. And that's really what this lesson is all about, getting kids talking about a variety of ways to solve one math problem. Let's get going.
So essentially, we want to get our students talking about a problem, and not only have but not have the conversation end at the answer 13 and then move on. What we really want is, once we've got the answer 13, now the conversation really begins, which is, how did you get the answer of 13? And allow the students a productive conversation where they come up with all the different methods for how they can show that 7 plus 6, in this case, is 13. For example, one idea might be, a student would say, well, I used 10 frames. 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 6. And then the student might say, at that point, I might have moved dots around. So they might have, taken some of these red dots and filled in. Oh, so I'm going to fill in 3 dots, which really kind of moves these dots. And so I can clearly see that my answer is 10 plus 3, and so the answer is 13. So the old classic fill in a 10 frame and see what you've got left over. That's one method. Another method, a student might say, well, I started with 7 plus 6, and I decomposed the 6 in order to make a 10. So now we have 10 plus 3, which is 13. Another student might start with 7 plus 6 and decompose the 7 and change it to 3 plus 4. And now we have a 10. So now we have 3 plus 10 is 13. Another student might say, well, I just started with 7 dots, 1, 2, 3, 4, 5, 6, 7, and then I counted on 6 more. 1, 2, 3, 4, 5, 6, and I can see that I get 13, or maybe probably a more likely way they would have done it. They would have said 7, and then 8, 9, 10, 11, 12, 13, and counting on their fingers, right? So there's a whole host of ways that a student might use to solve this problem, and the point of a number talk is to allow students to express all the different ways they can solve the problem so that students can begin comparing and contrasting methods, as well as appreciating efficiency, although efficiency is not the goal of a number talk. The real goal of a number talk is to just get kids talking about a variety of methods. So here, students are being asked to look at these examples and figure out which ones are correct and which ones are wrong. If it's wrong, we got to fix it. And I don't know if I have a particular thought about what students should do in order to go about this problem. Should they start with the problem and solve it themselves? In which case 9 plus 7, one way to do that would be to decompose the 7 in order to make a 10. Here's our 10. So we've decomposed 7 to be 1 plus 6. And so 9 plus 1 is 10. 10 plus 6 is 16. Oh, so the answer is 16. And we can see that that's 16 and this is 16. And oh, actually, by doing this, look at this. This tells me that Joe, he goofed up. Now, how did he goof up? Well, my decomposition of 7 is 1 plus 6, but his decomposition of 7 is 1 plus 5. Now, parents and teachers, I'm not sure what the right way to do, go about helping a student correct somebody else's work. So play it by ear. Let your students figure it out. If all else, breaks loose, just have them solve the problem and figure out which one doesn't come up right, and then look at that problem closely to see if we could figure out why it doesn't work, what happened, what mistake occurred. One more example of this. Oh, let's do 7 plus 6. So let's solve it for 7 plus 6. Now the cool thing about this one, I'm going to get a little crazy here. Let's leave the 6 alone. Let's decompose the 7. Why? Because I can. And so I've decomposed the 7 so that we can have a 10. Here's our 10. So 6 plus 4 is 10. And so our sum is 13. So we know our answer should be 13. And we can see, well, all of them are 13. Every single answer is 13. So that suggests to us that we are correct. Let's take a moment and take a look and see why Mary's method works. Well, what's the 7? Where's the 7? Here's the 7. Where's the 6? Oh, here's the 6, and that's why the answer is 13. Now, the idea is, how did we get 10 plus 3? Well, we used to have, I can see it, it's right down here. We used to have 7 plus 6, but when you decompose the 7, you end up getting 10 plus 3. Another way we could have shown Joe's work is we could have said, well, here's our 10 frame, 1, 2, 3, 4, 5, and here is another 10 frame, 1, 2, 3, 4, 5, and the idea would be we're going to decompose the 7. So the idea is, let's start with our 6 over, let's do it here, 6. 1, 2, 3, 4, 5, 6. Now the 7, because we're doing 7 plus 6, but the 6 we're putting right here. And then the 7 would be 1, 2, 3, 4, 5, 6, 7. And that's essentially what we have here, is here's our 6, and here, scattered, is our 7. And that's what they have here. So here's our 3, 4, 5, 6, 7. So there's the 7, and then there's the 6. All right. So we can see in the problem where each of those numbers come from. And that's the idea. We really want to just celebrate solving the same problem in a variety of ways. And so this lesson, that's first grade Module 2, Lesson 11, we are looking at a variety of solution strategies, understanding why they work, and we are appreciating that some of them are efficient, some of them are not, but as long as they lead to the correct answer, hey, we're going to be happy.